support multiple format in Apache POI Excel. HSSF is the POI project's pure Java implementation of the Excel 97 2007 file format. XSSF is the POI project's pure Java implementation of the Excel 2007 .xml.xlsx file format. Here you can see Apache POI library. You can see interfaces and classes in Apache POI. Workbook, it represents an Excel workbook. It is an interface implemented by HSSF workbook and XSSF workbook. Sheet, it is an interface that represents an Excel worksheet. A sheet is a central structure of a workbook which represents a grid of cells. The sheet interface extends java.lang.iterable. Row, it is also an interface that represents the row of the spreadsheet. The row interface extends java.lang.iterable. There are two concrete classes, HSSF row, XSSF row. Cell, it is an interface. It is high-level representation of a cell in a row of the spreadsheet. HSSF cell and XSSF cell implement the cell interface. Here you can see interfaces and classes. You can in the interfaces you can see workbook, sheet, and row and cell. In classes you can see HSSF workbook, XSSF workbook, likewise. Here the workbook is implemented by HSSF and workbook and XSSF workbook. Here interface sheet is implemented by HSSF sheet class and XSSF sheet class. Here interface row is implemented by HSSF row class and XSSF row class. Here interface cell is implemented by SSF cell class and XSSF cell class. Here you can see a spreadsheet API feature summary. SXSSF since POI 3.8 beta 3. Since the 3.8 beta 3 POI provides a low memory footprint of SXSSF API built on top of XSSF. SXSF is an API compatible streaming extension of XSSF. To be used in a very large spreadsheet have to be produced and heap space is limited. XSSF archives its low memory footprint by limiting access to the rows that are within a sliding window, while XSSF gives an access to all rows in the document. All the rows that are no longer in the window become inaccessible as they are returned to the disk. Auto flush mode, the size of the access window can be specified to hold a certain number of rows in the memory. When that value is reached, the creation of an additional row causes the row with the lowest index to be removed from the access window and written to disk. Or the window size can be set to grow dynamically. It can be trimmed periodically by an explicit call to flush rows in keep rows as needed. Due to the streaming nature of the implementation, there are following limitations when compared to XSSF. Only a limited number of rows are accessible at a point in time. Sheet.clone is not supported. Formula evaluation is not supported. The table here synopsizes the comparative features of POI's spreadsheet APIs here. Here you can see API type here HSSF or .xls, event model, user model. Here is streaming, in event model is streaming here according to sex, and in memory user model in memory tree according to DOM, and here XSSF or .xlsx event model is streaming according to sex, and user model in memory tree here according to DOM, and SXSSF buffered streaming here, and here CPU and memory efficiency here in event model is good, here user model varies, and event model good, and user model varies, and buffer streaming good. Forward only here is yes, and in HSSF user model varies. HSSF in event model is good, and in user model varies, and it with SXSSF is good, is yes. Sorry, in the event model is yes, and user model is no, and SXSSF is yes. Read file in HSSF it's yes, and in event model and user model in HSF it's yes, and with SXSF is no. And write files in event model in HSSF is no, and in user model is yes. In event model in XSSF no, and in user model yes, and in SXSF is yes in buffered. Features create sheets, rows or cells in event model in HSSF is no, and in user model yes, and event model in XSSF is no, and user model yes, and in SXSF is yes. Styling cells in event model in HSSF is no, and in user model HSSF is yes, and in event model in XSF it's no, and in user model yes, and in SXSF yes. Delete sheet and delete sheets, rows or cells in event model in HSSF is no, and user model yes. In event model in HSSF is no, and in user model yes, and in SXSF is no. Shift rows in event model in HSSF is no, and in user model yes. In event model in XSSF is no, and user model yes, and SXSF no. Cloning sheets event model HSSF is no, and in user model in HSSF yes. and in event model in XSSF Snow and user model yes, and SX SSF Snow. Formula evaluation in event model in HSSF Snow and user model yes, and event model in XSSF Snow and user model yes, and SX SSF Snow. Cell comments in event model in HSSF Snow and user model yes, event model in XSSF Snow and user model yes, and SX SSF Snow. Pictures event model in HSSF Snow and user model yes, event model in XSSF Snow and user model yes, and SX SSF yes. As an example, we can consider this code segment. Here we can focus on this class HSSF workbook, high-level representation of a workbook. This is the first object most users will construct whether they are reading or writing a workbook. It is also the top-level object for creating new sheets, etc. As an exception example, we can consider java.io exception. If anything can't be written in write java.io.file method in class HSSF workbook, as an example 2, we can consider this code segment. Here you can see class XSSF workbook, high-level representation of a spreadsheet workbook. This is the first object most users will construct whether they are reading or writing a workbook. It also the top-level object for creating new sheets, etc. As an exception example 2, we can consider java.io exception. It can be thrown in method add picture java.io.input stream int in class XSSF workbook. As an exception example 3, we can consider this exception in thread main java.io exception invalid header signature read 0x001000000600809 expected 0xe11ab1 a1 e011 cd cfdo. This error occurred during the execution of these statements. POI HSSF and POI XSSF and SX SSF related to Java API to access Microsoft Excel file formats. For Excel format files. HSSF is the POI project's pure Java implementation of Excel 97 to 2007 file format. XSSF is the POI project's pure Java implementation of the Excel 2007 .xml .xx file format. HSSF and XSSF provides a way to read spreadsheets, create, modify, and read and write Excel as spreadsheets. They provide low-level structures for those with special needs. an event model API for efficient read-only access, and full user API for creating, reading, and modifying XLS files. For people converting from PO HSSF user model who wish to use the joint SS user model for HSSF and XSSF support, then refer the documentation. An alternative way of generating spreadsheet is via the Cocoon serializer, yet you will still be using HSSF indirectly. With Cocoon, you can serialize any XML data source, which might be ESQL page outputting in SQL, for instance, by simply applying the spreadsheet and designating the serializer. If you are merely reading spreadsheet data, then use the event model API in either org.apache.poi.hssf.event user model package or org.apache.poi.xssf.event user model package, depending on your file format. If you are modifying spreadsheet data, then use the user model API. You can also generate spreadsheet this way. Note that the user model system has a higher memory footprint than the lower level event user model, but has the major advantage of being much simpler to work with. Also, please be aware that as a new XSSF supported Excel 2007 OOXML.XL SX files are XML based, the memory footprint for processing them is higher than for the older HSSF supported XLS binary files. Now we are considering SSF since POI 3.8 beta 3. XSSF is an API compatible streaming extension of XSSF to be used when very large spreadsheets have to be produced and heap space is limited. Since 3.8 beta 3, POI provides a low-level memory footprint SXSSF API built on top of XSSF. SXSSF is an API compatible streaming extension of XSSF to be used when a very large spreadsheet have to be produced and the heap space is limited. SXSF achieves its low-level memory footprint by limiting the access to rows that are within a sliding window, while XSSF gives access to all rows in the document. All the rows that are no longer in the window become inaccessible as they are written to the disk. In auto flush mode, the size of the access window can be specified to hold a certain number of rows in memory. When that value is reached, the creation of an additional row causes the row within the lowest index to be removed from the access window and written to the disk, or the window size can be set to grow dynamically. It can be trimmed periodically by an explicit call to flush rows and keep rows as needed. Due to the streaming nature of the implementation, there are following limitations when compared to XSSF. Only a limited number of rows accessible at the point in time. Sheet.clone is not supported. Formula evolution is not supported. Now we are considering writing a new file in use API HSSF and XSSF. Here is some example code exported and adapted from apache.poi.xssf.div.hsf test class. The class HSSF workbook, high-level representation of a workbook. This is the first object most users will construct whether they are reading or writing a workbook. It is also a top-level object for creating new sheets. Sheets, etc. This is in the package org.apache.poi.hssf.user The high-level API package org.apache.poi.sss.user is what most people should use. Usage is very simple. Workbooks are created by workbooks are created by creating an instance of apache.poi.ss.usermodel.workbook. Either create a concrete class directly, apache.poi.ssf.usermodel.hssf workbook, or apache.poi.xssf.usermodel.xssf workbook, or use a handy factory class apache.poi.ss.usermodel.workbook factory. Sheets are created by calling create sheet from the existing instance of the workbook. Created sheet is automatically added in the sequence to the workbook. Sheets do not themselves have a sheet name, the tab at the bottom. You can you set the name associated with the sheet by calling workbook set sheet name, sheet index, sheet name encoding. For HSSF, the name may be in 8-bit format. HSSF workbook dot encoding compressed Unicode, or Unicode HSSF workbook dot encoding UTF-16. Default encoding for HSSF is 8-bit per char. For XSSF, the name is automatically handled as Unicode. Rows are created by calling create row. Row number from an existing instance of a sheet. Only rows that have cell values should be added to the sheet. To set the row's height, use just call set row height on the row object. The height must be given in twips, or 1 divided by 20th of a point. If you prefer this is there is also a set row high in points method. Cells are created by calling create cell column type from an existing row. Only cells that have values should be added to the row. Cells should have their cell type set to either cell.cellType numeric or cell.cellType string, depending on whether they contain a numeric or textual value. Cells must also have a value set. Set the value by calling set cell value with either string or double as a parameter. Individual cells do not have a width. You must set call set column width, call index width. Use units of 1 divided by 256 of a character on the sheet object. You can't do it on an individual basis in the GUI either. Cells are styled with cell style objects. In turn, contain a reference to an font object. These are created via the workbook object calling create cell style and create font. Once you created the object, you must set its parameters, colors, borders, etc. To set a font for a cell style, call set font object. Once you have generated your workbook, you can write it out by calling write output string from your instance of the workbook, passing it an output stream, for instance file output stream or servlet output stream. You must close the output stream yourself. HSSF does not close it for you. Here is some example code exported and adapted from apache.py.hssf.dev.hssf test class. Create a new file here. Create a new workbook. Create a new sheet. Declare a row object reference. Declare a cell object reference. Create 3 cell styles. Create 2 fonts objects. Set font 1 to 12 points type. Make it blue. Make it bold. Arial is the default font, and etc. Now we are considering event API is HSSF only. The code here is the code expert from org.apache.py.hssf.dev.efsssf, which is in CVS or source distribution, is reprinted here with the excessive comments. The class HSSF request and HSSF request object should be constructed registering an instance, so multiple instance of HSSF listener with each record dot SID you wish to listen for. This is in the package org.apache.py.hssf.event_user_model. The event API is newer than the user API. It is intended for immediate developers who are willing to learn a little bit of low-level API structures. It's relatively simple to use, but requires a basic understanding of the parts of an Excel file or willingness to learn. Advantage provided is that you can read an XLS with a relatively small memory footprint. One important thing to note with the basic event API is that it triggers events only for things actually stored within the file. With the XLS file format, it is quite common for things that have yet to be edited to simply not exist in the file. This means there may be apparent gaps in the record stream, which you either need to work around or use record aware extension to the event API. To use API, you construct an instance of org.apache.py.hssf.eventModel.hssf request. Register a class you create that supports the org.apache.py.hssf.eventModel.hssf listener interface using the HSSF request add listener, your listener recorded, the record SID should be a static reference number such as BOF record.sid contained in the class in Apache org.apache.poi.hssf.record. The trick is you have to know what these records are. Alternatively, you can call HSSF request.add listener for all records, my listener. In order to learn about these records, you can either read all of the Java doc in org.apache.poi.hssf.record package, or you can just hack up a copy of org.apache.poi.hsf.dev.efsf and adapt it to your needs. Once you have registered your listeners, in the HSSF request object, you can construct an instance of org.apache.poi.fs .filesystem and pass it to your Excel input stream. You can either pass this along with the request you constructed to an instance of HSS F event factory, via the HSSF event factory.process workbook events request file stream. From the method, or you can get an instance of document input stream from file system dot create document input stream workbook and pass it to the HSS F event factory.process events request input stream. Once you make this call, the listeners that you constructed receive calls to their process record record methods. With each record, they are registered to receive no until the file has been completely read. The code expert from org.apache.poi.hssf.dev.efh.ssf, which is in CVS, so the source distribution is reprinted below here with excessive comments. Here you can see the class event example. This method listen for incoming records and handles them as required. Parameter record, the record that was found while reading. The BOF record can represent either the beginning of a sheet or the workbook. assigned to the class level member. SST records store or array of unique strings used in Excel. Create a new file input stream with the input file specified at the command line. Create a new org.apache.poi.poisf poifs file system get the workbook Excel part stream in the input stream. Construct HSSF request object. Lazy listen for all records with the listener shown here. Create our event factory. Process our events based on the document input stream. Once all the events are processed, close our file system input stream and our document input stream. Don't wait to leak this. Now we are considering missing row dummy record in record aware event API HSSF only. This is called during the raw record phase, which is typically occurs before the cell records and indicates that the raw record for the given row is not present in the file. The class missing row dummy record, a dummy record for when we are missing a row but still want to trigger something. This is in the package apache.poi.hssf.event user model.dummy record. The other two dummy records are missing cell dummy record and last cell of row dummy record. Now we are considering XSSF and SAX event API. This example shows how to get a single noun sheet or sheet in the file. It is based on the example in SVN POI examples. So SRC main Java org Apache POI examples XSSF event user model from how to Java. The class XSSF reader. This class makes it easy to get an individual parts of an OOXML .xlsx file suitable for low memory SAC parsing or similar. It makes up the core part of the event user model support for XSSF. This is in the package apache.poi.xssf.event user model. If the memory footprint is an issue, Then for XSSF, you can get at underlying XML data and process it yourself. This is intended for immediate developers who are willing to learn a little bit low level structure of .xlsx files, and who are happy processing XML in Java. It's relatively simple to use, but requires a basic understanding of the file structure. The advantage provided is that you can read XX file with the relatively small memory footprint. One important thing to note: the basic event API is that it triggers event only for things actually stored within the file. With the XX file format, it is quite common for things that have yet to be edited to simply not exist in the file. This means that there may well be apparent gaps in the record stream which you need to work around. To use this API, you construct an instance of org.apache.poi.xssf.eventModel.xssf reader. This will optionally provide a nice interface on the shared string table and the styles. It provides methods to get the row get the raw XML data from the rest of the file. Which you will then pass to SACS. This example shows how to get at a single noun sheet. It is based on the example in SVN POI examples, SRC, main, Java, org, Apache POI examples, XSSF, event user model from how to Java. To look up the sheet name to look up the sheet name sheet order RID, you need to process the core workbook stream. Normally it's of the form of RID hash or R sheet hash. Now we are considering SSF streaming user model API. When the row counts reaches 101, 101, the row with row num equals 0 is flushed to the disk and removed from the memory. When row num reaches 102, then the row with row num equal 1 is flushed, etc. SSF package org.apache.poi.xssf streaming here, and the class XSSF workbook, streaming version of XSSF workbook implementing the big grid demo strategy. This allows to write a very large files without running out or memory as long as only a configurable portion of the rows are kept in memory at any one time. You can provide a template workbook which is used as the basis for the written data. Please note that there are still things that still may consume a large amount of memory based on which features you are using. For example, merge regions commands are still only stored in memory and thus may require a lot of memory if used extensively. SX SSF workbook defaults to using inline strings instead of shared string table. This is very efficient since no document content needs to be kept in memory, but is also known to produce documents that are incompatible with some clients. With shared strings enable, all unique strings in the document has to be kept in memory. Depending on your document content, this could use a lot more resources than with the shared strings disabled. Carefully review your memory budget and compatibility needs before deciding whether to enable shared strings or not. This is in the package apache.poi.xssf.streaming. SSF package org.apache.poi.xssf streaming is an API compatible with streaming extension of XSSF to be used when very large spreadsheet have to be produced and the heap space is limited. SXSSF achieves its low memory footprint by limiting access to rows that are within a sliding window, while XSSF gives access to all rows in the document. The older rows that are no longer in the window become inaccessible as they are written to the disk. You can specify the window size at the workbook construction time via the new SXSF workbook int window size, or you can set it per via SXSF sheet hash set random access window size int window size. When a new row is created via create row, then and the total number of unflashed records would exceed the specified window size, then the row with the lowest index value is flushed and cannot be accessed via get row anymore. The default window size is 100 and defined by SXSF workbook.default window size. The window size of -1 indicates unlimited access. In this case, all records that have not been flushed by a call to flush rows are available for random access. Note that SXSF allocates temporary files that you must always clean up explicitly by calling with the dispose method. SXSF workbook default to using inline strings instead of shared strings table. This is very efficient since no document content needs to be kept in memory, but is also known to produce documents that are incompatible with some clients. With shared strings enabled, all unique strings in the document has to be kept in memory. Depending on your document content, that this could use a lot of resources than the shared strings disabled. Please note that there are still things that still may consume a large amount of memory based on which features you are using. For example, merge region, hyperlinks, comments are still only stored in memory and thus may require a lot of memory if used extensively. Carefully review your memory budget and compatibility needs before deciding whether to enable shared strings or not. The example below here writes a sheet with the window of 100 rows. When the row count reaches 101, the row with row number 0 is flushed to the disk and removed from the memory. When row number reaches 102, then the row with row number equal 1 is flushed, etc. To keep 100 rows in memory, exceeding rows will be flushed to the disk. Rows with row number less than 900 are flush and not accessible. The last 100 rows are still in memory. Dispose of temporary files backing this workbook on disk. Now we are considering low-level APIs. Apache.poi.hssf.record. It consists of a lot of records in the Apache.poi.hssf.record record.asterisk package and set of helper classes in Apache.poi.hssf.model.asterisk. Package Apache.poi.hssf.record. Record package contains class representation for XLS binary structures. It's very low level. The low level API is not much to look at. It consists of a lot of records in the Apache.poi.hssf.record.asterisk package and set of helper classes in Apache.poi.hssf.model.asterisk. The record classes are consistent with the low-level binary structures inside BIFF8 file, which is embedded in POIFS file system. You probably need to look the book Microsoft Excel 97 Developer Kit from Microsoft Press in order to understand how these fit together, out of print but easily obtainable from MSN's used books. In order to gain a good understanding of how to use the low-level API, should view the source in Apache.poi.hssf.usermodel.asterisk and classes in Apache.poi.hssf.usermodel.asterisk. You should read the documentation for POIFS libraries as well. Now we are considering generating XLS from XML. In Cocoon, there is a HSSF serializer which takes XML in generic table format and outputs an XLS file for you. The HSSF serializer, the HSSF serializer catches a SAC event and create a spreadsheet in the XLS format used by Microsoft Excel, but the output looks just dandy in GNumeric or OpenOffice.org as well. If you wish to generate XLS files from some XML, it is possible to write your own XML processing code and then use API to write out code. The other option is to use Cocoon, and in Cocoon there is a HSSF serializer which takes XML in generic format and outputs an XLS for you. Using the HSSF serializer is very simple. You will need a sitemap, of course. Once you have that, well, you are half there. Into the map colon serializers section of your sitemap, the local is optional and used only to validate numbers. Please note that numbers not in US default format may not be compatible with genumeric. It's less cosmopolitan than the HSSF serializer. Setting the local lets you to use the default number formats from the other locals. Set this to a 2-letter lowercase country code. See java.util.local.details for details. Next, set up an entry for each URL. Or set of URL via matching rules resembling this. The most important question is now is what XML the serializer is fed. Now we are considering HSSF class or test application. To run it, follow this. The package org.apache.poi.hssf.dev. The dev package serves two purposes. Example for how to use HSSF tools for developing and validating HSSF. The HSSF application is nothing more than a test for a high-level API and indirectly the low-level support. The main body of its code is repeated previously. To run it, download the POI alpha built and untied tar xvzf tarball.tar.gz. To set up your class path as follows: export HSF dir equal whatever you put HSS jar files, export log for JDIR whatever you put in log4j jar file, and export class path equal $class path colon $HSSF dir hssf.jar colon $HSSF dir POIFS.jar colon $HSSF dir POI util.jar colon $log4j jar dir / log4j.jar. Type java org.apache.poi.hssf.dev.hssf. Title / my xls right. This should generate a test sheet in your home directory called myxls.xls. Type java org.apache.poi.hssf.dev.hssf. Title / input.xls output.xls. This is the read write modify test. It read in a spreadsheet, modifies a cell and write back out. Failing this test is not necessarily a bad thing. If HSSF tries to modify a non-existent sheet, then this will most likely fail, no big deal. Now we are considering HSSF developers tools. We have already discussed app for testing HSSF read write modify capabilities. Now we will talk about a bit about Biffweaver, a class Biffweaver, utility for reading in BIFF 8 records and displaying the data from them. This is in the package org.apache.py.hssf.dev. The HSSF has a number of tools useful for developers to develop stuff using HSSF and more generally XLS files. We have already discussed the app for testing HSSF read write modify capabilities. Now we will talk about a bit about Biffweaver. Early in the development of HSSF, it was decided that knowing what is in a record that was wrong in it, etc., was virtually impossible with available tools. So we developed Biffweaver. You can find it at org.apache.py.hssf.dev.biffweaver. It performs two basic functions and derivative. The first is biffview. To do this, you run it and assumes you have everything set up in your class path and that you know what you are doing enough to be thinking about this. With an XLS file as a parameter, it will give you a listing of all understood record with their data and a list of not yet understood records with no data because it doesn't know how to interpret them. This listening is useful for several things. First, you can look at the values and assess what is wrong in the quasi-English. Second, you can send the output to a file and compare it. The second function is the big frequent dump. Just pass the file and second argument matching BFD exactly. This will make a big hex dump of the file. Lastly, there's a mixed mode which does the same as a regular biff view, only it includes hex dumps of certain records intervened. To use, just pass a file with the second argument matching on exactly. As an exception, example 4, we can consider this one, java.io exception, read error, and etc. This exception is occurred in this line in this code segment, and this code segment is under Apache POI 3.8. Now this is the end of my presentation. Thank you very much for watching it.